and principal and HOD of VCT, HOD of Department of Computer Science and Engineering and VCT. I special thanks to Lata Jyoti ma'am and Kailvili ma'am for inviting me for this AICT sponsored STTP on IoT with blockchain application and challenges. Thank you, Kyle, for inviting me this forum. Um, okay,
Welcome.
first, yeah, let me share my screen first. Am I audible to everybody?
Yeah, it's
Yes, Kyle,
audible.
am I audible? Yeah,
It's
okay,
audible.
thank you. Okay, thank you.
Your screen is also visible.
Yeah, okay, thank you, Kyle. Yeah. See, this lecture is about blockchain introduction and evaluation.
இதுக்குள்ளேயே போட்டுக்கிட்டு
So let me
ஒரே
start with when you give yes. See, see, when you give this blockchain word in a Google, you could find nearly 22 44 billion results, which says about it is trustworthy. You can find these buzzwords about blockchain, like where you will be provided with information such as it is a trustworthy, which means like you don't need central authority and trust finance. It is sounds very good, right? Then you may come up with statements that is it is incorruptible, um, immutable, and distributed system. What does it mean? Well, I also hear that people says BC, that is blockchain, is Bitcoin. The only application of blockchain is cryptocurrency, and blockchain can be useful only in financial sector, which is not actually true. It is like say it is not. Actually, for blockchain, we can find a lot of application with respect to blockchain. It is not only with respect to cryptography. We can find a lot more application in it. I think I will touch upon those applications later. Um, See, it is not just an it's just an online distributed system which can store information. That's all. That is what do you mean by blockchain? We can simply say it is an online distributed system which can store information. So actually, my goal of this session is that like at the end of this session, everybody will know the basics of blockchain and how it can make this world a better place to live for everyone. Actually, this technology was first described in the year 1991 by a group of researchers, but it never been realized its importance until 2009 when a cryptocurrency, Bitcoin, used it as a first blockchain based cryptocurrency. Well, what is our current knowledge about blockchain? We know that it is an online distributed system and which can store information, right? Okay, so we'll add some more detail in addition to that. Like it is based on interconnected blocks which are open to everyone. So, like it is very clear from its name, blockchain, right? It is a chain of connected blocks which can store information. So there are three things are will be available with every block. That is data, then hash of that block, then a hash of previous block. So this is the three content available in each block. content importantly. Okay, so like data, that is data is nothing but that is the information that we store on block, and that depends on type of blockchain. For example, if we take cryptocurrency, we store details about a sender, receiver, and the transaction. Then next is a hash of block, that is every block will contain the corresponding hash value. It is like a fingerprint of that block, it is always unique. We use that hash to identify the block. And the third one is hash of previous block, that is which connect the current block with the remaining blockchain. That make sure that the property which make this technology so secured. It is also providing another property which make more security, is that peer-to-peer nature of work. Like instead of having a central authority, which normal banks have, no, that they'll usually bank will have the central authority where it has all the information. Your blockchain just break the rule of central authority, where like every block, that is every user can see the rest of the block details. So with that small introduction, I would like to start this session. I hope you have some idea about what is blockchain, right? Okay, so the blockchain is nothing but it is an online distributed system, and the structure of the block contains three field. One is the data, then hash of that block, and the previous hash block value. Okay, so my agenda of this session is going to be like, first we'll discuss what is blockchain, then type of blockchain, then key features of blockchain, then followed by components of blockchain, then how does a blockchain works, then structure of blockchain, then evaluation and various use cases pertaining to blockchain, and finally we'll discuss about blockchain and COVID-19. And I also have an idea to demonstrate one blockchain application with you all. Okay, so we'll start with blockchain. Okay, as you know that like blockchain, it is a distributed ledger technology. We can simply call it as a blockchain technology. Actually, it is referred to the technology behind decentralized databases, providing control over the evaluation of data between entities through a peer-to-peer network using consensus algorithm that ensure the replication across the nodes of the network. Okay, so actually the blockchain, it is a digital record. Okay, so here a group of transaction is combined together as a block. Okay, a transaction, it is nothing but a block, and a block, it is combined chronologically to form a chain. Okay, so here the important algorithm we are using here is a consensus algorithm, and we have another terminology that usually come up with the blockchain is smart contract. Okay, I will have also have some couple of slides about a smart contract that we will see later. So like we can more simply we can say that for example, imagine a book that anyone could obtain and free of charge, where anything written on its page would be there forever, and at the same time would be cross-referenced with other books to check whether what was written to be valid and true. Okay, so that is the essence of your distributed ledger technology, or we can say it is a blockchain. Okay, so like that your block it is open to all, and we can obtain it free of charge. Then anything written on the book, likewise anything whatever the content available in the blockchain block, that can be remain as such, and nobody can change the content of the block, and anyone can see the block. Okay, so then the validation, that is the reliability of the content. Okay, that is also be ensured in our blockchain technology. Okay, so the type of blockchain. Okay, so when we say type of blockchain, there are three types of blockchains. One is the public blockchain, then federated blockchain, and private blockchain. So here, like we have this diagram actually shows the public and private blockchain. Public means it is open to all. Anyone can obtain the public blockchain network, whereas private is it's specific about a particular organization. Okay, so let me start with type public blockchain. Actually, there are different kind of blockchain technology you can use. One of them is public blockchain. The name lets you know everything, right? So such a blockchain network is entirely open for everyone. No one needs any permission to participate in the blockchain or query about it. Any transaction process through this kind of blockchain is validated for all. Everyone has a right to download the code and run any public node on their own device. Then anyone can even check the current status and also decide to add any blocks to the chain. Other than that, you can easily join the network without any hesitation. And the most attractive part is that they don't need any kind of validation permission from anyone. So such characteristics attract more people to be a part of the blockchain technology, uh, as it is explained as public, right? Okay, so the system server does not require any maintenance. So that is why the decentralized application don't cost too much to create and run them. So one of the leading blockchain network is Bitcoin. Other than Bitcoin, we have Ethereum, Dash, then Dongcoin, then Litecoin are also a different blockchain network. So all these blockchain networks have the access for anyone to join as participant, use their codes, and also send any transaction, or even they can read the transaction. So that is about the public blockchain. So next we have a private blockchain. So before going to the private blockchain, we will see what is federated blockchain, because your federated blockchain, the characteristics is falls between public and private blockchain. Okay, so the next type of blockchain is a federated blockchain, or we can say it is a consortium blockchain. So it is a kind of opposite, just opposite to the public blockchain network. That is actually people do not get access to the ledger or any kind of transaction verification process, right? So everyone does not have a right to read this blockchain. Whereas when we say about a blockchain, anyone can directly access the block, and they don't need any permission, or they don't need to get permission from a third party, right? But in the federated blockchain, they need to, like, they everyone doesn't have right to read the blockchain. Actually, this kind of blockchain, it is formed based on a group of leaders. They operate the federated blockchain. So that is the main reason behind the name of this blockchain. The privacy of transaction is better in this system. They handle it with great care, and even their scalability is higher than a public one. Okay, so the next comes to the private blockchain. In some cases, you can say that the main difference between private and federated blockchain is that except a group of organization, only a single one control the process of the entire private blockchain network. Okay, see, if you take a public blockchain, everyone, okay, everyone can have a control on it. But when we say a federated blockchain, only group of leaders having a control on accessing the blockchain. private blockchain is nothing but a single person have control the process of private blockchain. So usually, people don't have access to the blockchain network, such as auditing and database managing. So individual companies can get access with a proper permission and process. They'll be able to access in transaction verification internally, but there are cases where the public can get a chance to audit. And the private technology, it is opposite to the public one in some cases, and it is a centralized system. With the private blockchain, the security break risk increases. The transaction cost is less with respect to private blockchain network. They change the inheritance system. Handling document is way simpler with this blockchain network. And multi-chain and monax are two private blockchain networks. So these are only some example of private blockchain. So that's the different types of blockchain. So generally we have three types: public blockchain, private blockchain, and federated blockchain. So simply we can say that public blockchain, this will be controlled by all the user, whereas a private blockchain, it is comes under the control of single person. And federated blockchain, it comes under the control of a group of persons. Okay. um, so the next is like key features of blockchain technology. Okay, so when we say immutability, decentralized, and blockchain is a enhanced security, we can provide a more security with respect to blockchain. And blockchain, it is a distributed ledger, and it is a consensus. And the last feature we'll be discussing is faster settlement. So when we say immutability, actually generally the immutability means something that cannot be changed or altered. So this is one of the top blockchain feature that help to ensure that the technology will remain as it is, that is a permanent and alterable network. But how does it maintain that way? Actually, the blockchain technology works slightly different than the typical banking system. So instead of relying on a centralized authorities, it ensures the blockchain features through a collection of nodes. That is, every node on a system has a copy of digital ledger. To add a transaction, every node needs to check its validity. If the majority thinks it is a valid, then it is added to the ledger. So this promotes transparency and make it a corruption proof. So without the consent from the majority of nodes, no one can add any transaction block to the ledger. So I'll give you one scenario. Let's say, for example, they have three user, like user A, B, and C. So initially they have added in the network, in the blockchain network. And they that is in the block, they will have the amount of 100 rupees. Let's say, for example, each user will have the amount of 100 rupees. And the user A knows what the amount is available with B and C. Likewise, B also know about A and C also know about B and C. So let's say, for example, now this user A wants to transfer the amount to B for 50 rupees. They want to transfer the amount from A to B, 50 rupees. Okay, so now C knows that, okay, A can able to transfer the amount 50, so that they will be accepting that transaction. And B also know that, okay, they have 100 rupees totally, so they can able to transfer 50 rupees. Now what happens if C wants to transfer the amount of 200 rupees? So A and B already know their amount, know the amount of C. So now they will not accept the transaction, because the C is already having only 100 rupees, and now they are placing the transaction as 200 rupees. this will not be acceptable. Okay, so such kind of facilities are available, like a majority. So that is the other user must accept the transaction. Okay, they can able to do the transaction with the amount of 50 rupees, but transaction with the amount of 200 is not possible, right? Okay, so that kind of facilities are available with respect to blockchain technology, because every user knows the details about the other user, what type of transaction they can able to do, whether the transaction is permittable, whether the transaction is valid. Anything can be verified through your blockchain network. Okay, so with respect to decentralized, okay, so that is the network is decentralized, meaning that it does not have any governing authority or a single person looking after the framework. So rather, a group of nodes maintain the network, making it decentralized. This is one of the key feature of blockchain technology that works perfectly. Let me make it simpler. Blockchain put a user in a straightforward position. As the system does not require any governing authority, we can directly access it from the web and store our asset there. So you can store anything starting from cryptocurrencies, important document, or any contract, or other valuable digital assets. Anything can be made available in your it is not only about a cryptocurrency. We can store any audio, any video file, or any agreement, like that. We can store it in anything in our block, but it should be in a digital manner, right? So and with the help of blockchain, you'll have direct control over them using your private key. So you see, the decentralized structure is giving the common people their power and right back on their asset. Okay, so the next feature is enhanced security. Okay, as get rid of the need for a central authority. No one can just simply change any characteristics of the network for their benefit. So using encryption ensures another layer of security for the system. But how does it offer so much security compared to already existing techniques? Well, it is extremely secure because it offers a special technique called cryptography. Added with a decentralization, cryptography lays another layer of protection for users. So cryptography is a rather complex mathematical algorithm, as we all know that cryptography involves a mathematical algorithm that act as a firewall for attacks. So every information on the blockchain is hashed cryptographically. In simple terms, the information on the network hides the true nature of the data. So for this process, any input data gets through a mathematical algorithm that produces a different kind of value, but the length of the data is always fixed. You could think of it as a unique identification for every data. Like all the blocks in the ledger come with unique hash of its own and contain the hash of the previous block. So changing or trying to tamper with the data will mean changing all the hash IDs, and that it is not possible. Actually, you'll have a private key to access the data, but we'll have a public key to make a transaction. Okay, so we'll be having both private key as well as public key for performing the transaction. So the next is distributed ledger. Okay, so the this feature actually usually a public ledger will provide every information about a transaction and the participant. So it is all out in the open, never nowhere to hide that. These information will never be hidden, although the case for private or federated blockchain is a bit different, but still in those cases, many people can see what really goes on in the ledger. This is because the ledger on the network is maintained by all other users on the system. It is not with respect to single user. So each and every user in a blockchain is responsible for maintaining the ledger. So this distributed computational power across the computer to ensure a better outcome. So that is the reason it is considered one of the blockchain essential feature. So the result will always be higher efficient ledger system that can take on the traditional one. So the next is consensus. Actually, every blockchain grows strongly because of the consensus algorithm. So the architecture is cleverly designed, and the consensus algorithm are the core of this architecture. Every blockchain has a consensus to help the network to make a decision. So in simple terms, the consensus is a decision making process for the group of nodes active on the network. Like here, the nodes can come to an agreement quickly and relatively faster with the help of consensus algorithm. That is, whether the particular transaction is valid, whether the particular transaction is acceptable. Okay, so that kind of decision making is done very quickly with the help of consensus algorithm. When millions of nodes are validating a transaction, a consensus is absolutely necessary for a system to run smoothly. So you could think it of like a kind of voting system where the majority wins and minority has to support it, right? Okay, so the same is followed here also. Like nodes might not trust with each other, but they can trust the algorithm that run at the core of it. So that is why every decision on the network is a winning scenario for the blockchain, and it is one of the benefits of blockchain feature. So the last features that we are going to discuss here is faster settlement. Okay, when we say like a traditional banking system are quite slow. Sometimes it can take days to process a transaction after finalizing all settlement. It also can be corrupted quite easily, right? So, but blockchain it offers a faster settlement compared to traditional banking system. This way, a user can transfer money relatively faster, which saves a lot of time in the long run. These blockchain features make life easier for foreign workers and help to understand why blockchain is important. Like many people travel to another country in search for a better life and job and leave families behind. However, sending money to their family overseas takes a lot of time and could become fatal in times of need. So now blockchains are a way too fast, and they can easily use it to send money to their loved ones. And like another fun fact is that the smart contract system I already noted, no, like a smart contract system. So this can allow making faster settlement for any kind of contract. So this is one of the best benefits of blockchain features to this day. And with the third party out of the way, people can send money with a minimal fee. Right, like this way blockchain will impact international trades too. And these are the core features that I have identified with respect to blockchain technology. Like it is immutability, and we can have the decentralized. We can establish a decentralized network here, and the securities. very high, like then it follows the distributed ledger, like traditional system, and for making a decision whether to accept a particular transaction, we need to use consensus algorithm, and here we can perform the transaction very quickly. So that is the important thing with respect to blockchain technology. And the components, that is what are the things we have inside the blockchain, that is how the blockchain is being formed. These are the important components we can find pertaining to blockchain, that is a node, transaction, block, then chain, miners, then consensus. Okay, so like node, when we say node, user, it is nothing but like user or a computer within the blockchain. A transaction is nothing but it is the smallest building block of a blockchain system, that is what operation we are performing inside the block. Okay, then a block, it is nothing but it is a data structure used for keeping a set of transaction which is distributed to all nodes in the network. So what is a block? Block, actually it is a data structure used for keeping a set of transaction which is distributed to all nodes in the network. Then a chain is nothing but it is a sequence of block in a specific order. Then a miners, it is like a specific node which perform the block verification process. Okay, so like in a particular blockchain network, we can have one or more than one miners, or every node can act as a miner. So the job of miner is to perform the verification process. So let's say in a blockchain network, if one user wants to perform one a transaction, okay, so that transaction needs to be validated. Then who will validating the transaction means the miner. So miners are responsible for validating particular uh, transaction. It is not like for every blockchain we'll be having only one miners. It is not like that. We can have more than one miners at the same time. Sometimes what happen now, every node can become a minus. That is also possible. Then finally, the last component that we need to consider in the blockchain is consensus. It is nothing but a set of rules and arrangements to carry out a blockchain operation. Okay, so these are all the core components we could find in a blockchain, that is a node, a transaction, a block, a chain, miners, and consensus. So, how the blockchain works? Actually, there are 6 steps has to be followed strictly. Like when the transaction is requested, like whenever a particular user wants to perform a transaction, first the transaction needs to be requested. So then your block that represent the transaction is created, and then the block is sent to every node in the network. Okay, so first the transaction will be created, then for that particular transaction a block is created, and then the created block is sent it to every node in a network. Okay, so now the node will validate the transaction whether it is a valid transaction or not. Okay, so that is miner. So miner will take care of validating the transaction, and the node receive a reward for the proof of work. That is, if it is a valid, then the corresponding nodes will receive the reward for proof of work. Okay, so finally, once your transaction become a valid one, the block is added to the existing blockchain, and then the transaction gets completed. So these are all the 5 steps that has to be followed strictly in order to perform a transaction on your blockchain. So what is that? First, the transaction is requested. Then but for that transaction, a block is created, and the block will be sent to every node in a blockchain network, and the block will be validated. Once it is validated, the proof of work reward is received, and then the block is added in the existing blockchain network, and finally the transaction gets completed. So once the transaction is completed, nobody have rights to change the transaction. That is the beauty we have in the blockchain works, because when the block is created itself, some hash values generated, and when once it is validated, the previous block hash value is inserted in it. Okay, so if anybody, if hackers wants to hack a particular block, means that is not actually possible. Even if they have changed, it will reflect the next block also. So then if they are doing the block, then it will be reflect to the next block. So like that, everybody will get to know that some hacking process is undergone in a particular blockchain network. Okay, so that is why we are saying that blockchain is very secured one, and no, the hackers cannot hack the content available in the blockchain. So that is the blockchain structure. Actually, we have a block number. It is the header one, and there, as I said, like we have three fields: no, data, then hash value, then previous hash value, right? Okay. So here it just point to the header. It points the block number. That is the first one contains the hash value of particular block. Okay, and then we have a hash value of previous block header, and then a Merkle root is nothing but actually it is a kind of hash tree where it will apply some algorithm in order to generate hash value for a particular block. Okay, so that is very very important. It's just like a Merkle tree, or we can say it is a hash tree. Okay, so every node in a Merkle, it contains a hash value of that particular block. So if you see here, we have three blocks. If you take a block 2, it contains like the block header value, and then hash value of previous header, that is block 1 hash value is available with that. Then it has the hash tree, and then block, that is the transaction that we are going to performed on a particular block. So the next is evaluation of blockchain. Actually, this slide give you the overview at what time the era of blockchain has been started, when it becomes more familiar across the world. Okay, so that is what we are going to discuss in this slide. Actually, in the year, as um, the beginning of this session, I told you that the blockchain, it has been started in the year 1991, but nobody have realized the importance of blockchain. Actually, when it comes to the Bitcoin cryptocurrency, that time only the blockchain becoming familiar across the world. How did blockchain emerge? Actually, we have some person like Haber, Scott Stornetta. So they have envisioned what many people have come to know as blockchain in 1991. The first work involved in blockchainers like working on cryptographically secure chain of blocks, whereby no one could tamper with the timestamp of document. Okay, so in 1992, what happened means they upgraded their system to incorporate Merkle trees that enhanced efficiency, thereby enabling collection of more documents on a single block. However, it is in 2008 that blockchain history starts to relevance. That is like we must thanks to the person who named as Satoshi Nakamoto. So he's accredited the brain behind the blockchain technology, and very little is known as like about Nakamoto. As he's people who believe that like he and he could be a person or a group of people that worked on Bitcoin, the first application of a digital ledger technology. And he also conceptualized the first blockchain in 2008, where the technology has evolved and found its way into many applications beyond cryptocurrencies. So actually, he has released first white paper about the technology in 2009. In the white in that white paper, he provided details of how the technology was well equipped to enhance digital trust, given the decentralization aspect. That mean nobody would ever be in control of anything. Um, so the next is like the next era starts at 2008, between 2008 to 2013. Actually, this is the time where your Bitcoin emergence. Like, so most people believe that the Bitcoin and blockchain. Yes, give me a minute. Um, 4 o'clock. இவங்க போயிட்டு Kyle, give me a 2 minutes time, Kyle. I'll come back.
No problem.
Yeah. Participant, sorry for the interruption. Actually, since I'm in college, some construction work is going, so I need to shift the place. That is why. Sorry for the interruption. Yeah. If am I audible to everybody?
Yes, madam.
Okay, okay.
Screen is also visible. You proceed, please.
Yeah, okay, okay.
Okay.
Uh, yeah. So where we are in the period 2008 and 2019, right? Um, okay. So here, in a world where innovation is the order of the day, Botin actually he is among a growing list of developers who felt Bitcoin had not yet been reached there when it uh, uh, came to using the full capabilities of blockchain technology as one of the contribution to the Bitcoin code base. Um, so Ethereum was born out as a new public blockchain in 2013 with added functionalities compared to Bitcoin, a development that has turned out to be a pivotal movement in blockchain history. Bertrand actually he differentiated Ethereum from Bitcoin blockchain by enabling a function that allows people to record other assets such as slogan, music, as well as like contract. So the new feature expanded Ethereum functionalities from being a cryptocurrency to being a platform for developing a centralized application as well. Officially, they launched in 2015. Ethereum blockchain has evolved to become one of the biggest application of blockchain technology, given its ability to support a smart contract used to perform various function. Um, Various functions. Then Ethereum blockchain platform has also succeeded in gathering an active developer community that has seen it establish a true ecosystem. And the Ethereum blockchain process the most number of daily transaction thanks to its ability to support a smart contract and decentralized application. Its market cap has also increased significantly in the cryptocurrency space. And the next era, like between 2015 to 18, and here we that is blockchain 3.0, the future of blockchain. Actually, the blockchain history and evaluation does not stop with Ethereum and Bitcoin. In the recent year, a number of projects have cropped up, all using blockchain technology capabilities. New projects have sought to address some of the deficiency of Bitcoin and Ethereum. In addition to coming up with new features leveraging blockchain technologies. The blockchain history discussed now involves public blockchain networks whereby anyone can access the content of the network. However, with the evolution of technology, the number of companies have started adopting the technology internally as a way of enhancing operational efficiency. Then large enterprises are investing a big in hiring professional as they seek to gain head start on the use of technology. Then companies like Microsoft and Microsoft appear to have taken the lead when it comes to exploring blockchain technology application, resulting in what has come to be known as a private, hybrid, and federated blockchain. In 2015, Hyper Ledger. Actually, in 2015, the Linux Foundation unveiled an umbrella project of open source blockchain. They went on to call it a Hyper Ledger. Instead of like a blockchain, they call it as Hyper Ledger, which until to date act as a collaborative development of distributed ledger. Then Hyperledger seeks to advance cross-industry collaboration for development of blockchain and distributed ledger. So mostly the Hyperledger focuses on encouraging the use of blockchain technology to improve the performance and reliability of a current system to support a global business transaction. And when it comes to the 2020, 20, the blockchain history and the future of blockchain technology. Um, the future of blockchain technology looks bright in part because the way the government and the enterprises are investing big as they seek to promote innovation and application. It is becoming increasingly clear that one day there will be a public chain that anyone can use. Uh, so that is how the evolution of blockchain carries since 1991 to 2020. The evolution of blockchain technology in recent years has increased the demand for blockchain professionals. The companies are also implementing blockchain to get benefits of blockchain applications, and finally we have a smart contract as I know no as I said no, like smart contract, it is nothing but just an agreement between two parties. Whenever one party makes a particular transaction, automatically it trigger the smart contract. Okay, so that will ensure whether the transaction is acceptable. Okay, so that kind of it just an agreement between two parties, while traditional contract require both parties to execute their responsibilities. Smart contract, it is a self-execute predefined action when specific condition associated with a given transaction are met. So an easy way to understand smart contract is to view it as a programmable money. For example, if you're a landlord and your tenant have leases. Okay, so the smart contract contains key data of both parties. Okay, so such as a name, then contact information, bank account detail, as well as the information about the lease itself, including a lease amount and the payment date. So when a smart contract self-execute on the predefined lease payment date, it automatically withdraws funds from the tenant bank account and deposit the funds into your account. So this saves you the monthly rental settlement in advance of reminding the tenant to pay, and from hounding the tenant once the late date has passed. So never mind eviction notices. Okay, then code the dates. Okay, anything can be we prepared as a smart contract when a particular condition, so condition means when the particular date comes, automatically the smart contract execute, then it will deduct amount from the particular user and deposit to another user. So, what do smart contracts have to do with the blockchain? Actually, the smart contracts are kept on the blockchain and are executed automatically when a transaction is processed. And because data on the blockchain is immutable and it cannot be changed or manipulated by anyone, smart contracts, once agreed upon, should help build trust between all parties, as neither side can play with the contract or its terms. Like uh, um, as you know, here first we'll be having a terms and details of agreement are coded in the smart contract. So whatever the terms between when we have some tenant, let's say we'll take the landlord and tenant. Okay, so at that in the beginning they'll have some terms and they'll have some agreement. Okay, so all those things are coded and kept as a smart contract. Then event or action trigger, the smart contract is executed, and actions such as payment notification, then API or a process, then transaction settlement and clearing are completely completed instantly. Okay, so next we'll see some benefits of smart contract. Then the first one is it is autonomy. That is, you are the one making agreement. There is no need to rely on a broker, lawyer, or other intermediaries to confirm. Like incidentally, this also knock out the danger of manipulation by a third party. So since execution is managed automatically by the network rather than by one or more people involved. Then a trust. So your documents are encrypted on a shared ledger. So there is no way that someone can say they lost it. Then a backup. So backup is another benefit we have for a smart contract. That is, imagine if you are a bank, if your bank lost your saving account. So on the blockchain, each transaction is recorded automatically. So safety, like cryptography, the encryption of website keeps your documents safe. There is no hacking. In fact, it would take abnormally smart hacker to crack the code and infiltrate. Then speed, actually, yeah, you would ordinarily have to spend chunks of time and paperwork to manually process the document. But by having the smart contract, the software code to we have software code to automate tasks, thereby saving hours of a range of business process. Then we have savings, that is a smart contract save your money since they knock out the presence of intermediary. You would, for instance, you have to pay a notary to witness your transaction. That is not actually required by when we have a smart contract. Then accuracy. Automated contracts are not only faster and cheaper, but also avoid the errors that come from manually filing out heaps of forms. Then when we have that is pros and cons of smart contract. That is the advantage of smart contract is since smart contract runs on blockchain technology, they provide security, economy and speed and standardization. That is, when we security, actually the smart contract is encrypted and distributed among nodes. Specifically, this guarantees that it will not be lost or changed without your permission. Then economy and speed, like the contracts have automated process and most eliminated mediator, okay, intermediator. Okay, then standardization. There is a wide a range of smart contract nowadays. You can choose one and change it according to your needs. And the disadvantages, like smart contracts aren't perfect. The following are the some obstacles smart contracts could not avoid, like human factor, uncertain legal status, then implementation cost. Human factor, people who write the code can make mistakes. If the smart contract is in the blockchain, it does not change. Then uncertain legal status, like currently, no government is regulating smart contract. As a result, there is a potential issue if governmental institution decide to make a legislative framework for smart contract. Then implementation cost. The smart contract cannot be performed without programming. It is very important to have an experienced coder on the staff to make fail-proof smart contract and adopt the internal structure of the company for blockchain technology. So now that we have discussed pros and cons of smart contract, let's look at where they can be applied. That is, the smart contract application. It can be applied in different fields such as election, logistic. Like election means like voting procedure can be complex. However, when voting results are put in the blockchain and distributed among the nodes of the network, they remain anonymous, and they will also eliminate many manipulation with the ballot. Then logistic means like the supply chain includes a lot of links. In addition, each link has to get a confirmation from the previous one, holds up its end of the contract and send information further. Also, it takes a lot of time to do the work on time. Also, smart contract ensure transparency in the contract terms as well as fraud protection. There are some other application, some other possible application, that is in management, the bank system, insurance, then real estate, IoT. We have a lot more applications where we can apply smart contracts. Okay, so let's next we'll discuss about consensus algorithm. Like we know that the blockchain, it is a distributed, decentralized network that provide immutability, privacy, security, and transparency. There is no central authority present to validate and verify the transaction. Every transaction in blockchain is considered to be completely secured and verified. So this is possible only because the presence of consensus protocol, which is the core part of any blockchain network. A consensus algorithm, it is a procedure through which all the peers of blockchain network reach a common agreement about the present state of the distributed ledger. So in this way, the consensus algorithm achieves reliability in the blockchain network and establish trust between unknown peers in a distributed computing environment. So essentially, the consensus protocol makes sure that every new block that is added to the blockchain is the one and only version of the truth that is agreed upon by all the nodes in a blockchain. So the blockchain consensus protocol consists of some specific objective, such as coming to an agreement, collaboration, cooperation, equal rights to every node, and mandatory participation of each node in the consensus process. So, thus, a consensus algorithm aims at finding a common agreement that is win for the entire network. So, for the consensus algorithm, we do have certain algorithms like proof of work, then proof of stack, and delegated proof of stack. Okay, so we have a lot more consensus algorithm that will help us to make a certain decision on a network. Like we have a proof of capacity, proof of activity, proof of burn. Okay, so out of these algorithms, we'll be discussing only these three algorithms, like proof of work, a proof of stack, and a delegated proof of stack. Actually, the proof of work actually is currently the most common and one of the most robust consensus mechanism for blockchain technology. The miner has to solve a mathematically complex puzzle on the new block before approving the block to the ledger. So after solving the puzzle, the solution is then forwarded to other miners and verified by them before being accepted to their respective copies of the ledger. So the transactions are finalized and approved by the miner after verification. So this is how the procedure followed for proof of work. Okay, so I told you, like whenever a particular transaction is going to happen, that must be validated by the miner. So how the miner will validate me? With the help of consensus algorithm. So proof of work is one of the algorithm through which we can validate the particular transaction. So how it is being validated? Like they'll be performing, so they'll be solving some mathematically complex puzzle on a new block before approving the block to the ledger. Okay, so the next is proof of stack. So the proof of stack is a substitute approach for proof of work, which require fewer CPU computation for a mining. So though this is also an algorithm, and the purpose is same as a POW, that is proof of work. The process is quite different here. That is, as in case of PO, that is proof of work, a miner is rewarded by resolving mathematical problem and creating new block. But with respect to proof of stack, the creator of new block is chosen in a deterministic way depending on its wealth, also defined as a stack. So this means that in the POS mechanism, that is proof of stack mechanism, there is no block reward. So the miners take the transaction fees. POS mechanism has its own pros and cons, and the actual implementations are quite complex compared with a proof of work. The proof of stack is quite complex. And the next one is delegated proof of stack. So this is nothing but like it is very different from POS, that is proof of stack. Here, token holders do not work on the validity of the blocks by themselves, but they select delegates to do the validation for them. In a delegated proof of stack system, there are usually between 21 to 100 selected delegates. The selected delegates are being changed periodically and assigned an order to deliver their blocks. If we have less number of delegates, it allows them to organize themselves efficiently and create a designed time slot to publish block. If the delegates miss their blocks on a regular basis or publish a invalid transaction, the token holder vote them out and replace them with some other selected delegates. Unlike proof of work and proof of stack, in delegated proof of stack, miners can collaborate to develop block. With a collaborative effort and a partially centralized process, DPoS it has been able to run order of magnitude which are faster than any other consensus algorithm. So other than these three, like proof of work, proof of stack, and a delegated proof of stack, we have proof of capacity, then proof of activity, proof of burn, then UNL, that is a unique node list. Okay, so these are some other consensus algorithm that will enable us to make a decision on validating particular transaction. Okay, so next is like uses of blockchain. So far we have discussed the introduction of blockchain, the various component of blockchain, then evolution of blockchain. Okay, so now we'll discuss about the use cases of blockchain. like um, so we can, as I said, it is not about a single application. We can use the blockchain technology in many applications like healthcare, supply chain management, voting mechanism, then real estate processing, then personal identity security. Okay, so in many areas we can involve blockchain technology. Actually, in COVID-19, okay, so how the blockchain, that is the role of a blockchain in COVID-19. Actually, in the COVID-19 coronavirus has impacted many countries and communities and individuals in countless ways, from school closure to healthcare insurance issues, not to undermine the loss of lives. Then, as government scramble to address these problems, different solutions based on blockchain technologies have sprung up to help deal with the worldwide health crisis. Like blockchain, it is an essential tool for establishing an efficient and transparent healthcare business model based on a higher degree of accuracy and trust, because a technology is tamper proof public ledger, and blockchain will surely not prevent the emergence of a new virus itself, but what it can do is to create the first line of rapid protection through a network of connected devices whose primary goal is to remind alert about disease outbreaks. So therefore, the use of blockchain-enabled platform can help prevent these pandemics by enabling early detection of epidemics, fast tracking drug trials, and impact management of outbreaks and treatment. So the major challenges of COVID-19 are like one major is how prepared the World Health System are to respond to this outbreak. Then tracking a huge population of infectious patients to stop epidemics. Then another is the immediate requirement for developing better diagnostics, vaccines, and targeted therapist. Then misinformation and conspiracy theories spread through the social media platform. Then another challenge is various limitation while accessing the tool when it is required, and no adequate measure to adopt in crisis situations. Okay, so can the blockchain help in preventing pandemics? Actually, with the help of a blockchain, we can share any transaction or information in real time between relevant parties present as node in the chain in a secure and immutable fashion. So um, in this in this case, there been a blockchain where WHO, health ministry of each country, and even relevant nodal hospital of each country were connected and sharing real-time information about any communicable disease. Then the world might have woken up much earlier, and we might have seen travel restriction given sooner, quarantining policies set sooner, and social distancing implemented faster, and maybe a few countries would have got impacted. The usage of blockchain to share the information early on, and might have saved the world a lot of pain. The world had not seen anything like COVID-19 pandemic before in the recent history. Today, we need to take hard look at the reporting infrastructure available for communicable disease. Both technology and the regulation improve upon that, such that we do not need to face another pandemic like this in the future. Then actually, these are like tracking, like the blockchain application in fighting COVID-19. These are all the various applications with respect to COVID-19, like securing medical supply chains, then crisis management, tracking infectious disease outbreaks, then donation tracking. So when we say like the blockchain that is tracking infectious disease outbreaks, like a blockchain can be used for tracking public health data surveillance, particularly for infectious disease outbreaks such as COVID-19. With increased blockchain transparency, it will result in more accurate reporting and efficient responses. Blockchain can help develop treatments swiftly, as they would allow for rapid processing of data, thus enabling early detection of symptoms before they spread to the level of epidemics. Then, additionally, this will enable a government agency to keep track of the virus activity of a patient then suspected new cases and more. Then donation tracking. As a trust is one of the major issues in donation, blockchain has a solution for this issue. There has been a concern that the millions of dollars being donated for the public or not being put to use where it is actually needed. With the help of blockchain capabilities, donors can see where funds are most urgently required, and they can track their donations until they are provided with the verification that their contributions have been received to the victims. So blockchain would enable a transparency for the general public to understand how their donations have been used and it is progress. Then crisis management. Blockchain could also manage crisis situations. It could instantly alert the public about the coronavirus by global institutes like World Health Organization using a smart contract concept. Not only it can alert, but blockchain could also enable to provide governments with a recommendation about how to contain the virus. It could offer a secure platform where all the concerning authorities such as government, medical professional, media, health organization, then other than can update each other about the situation and prevent it from worsening further. Then securing medical supply chain. Blockchain has already proven its success stories as a supply chain management tool in various industries. Similarly, blockchain could also be beneficial in tracking medical supply chains. The blockchain-based platform can be useful in reviewing, recording, and tracking of demand, then supplies and logistics of epidemic prevention materials. As supply chain involved multiple parties, the entire process of a record and verification is tamper-proof by every party, while also allowing anyone to track the process. So this technology could help streamline medical supply chains, ensuring that the doctors and patients have access to the tools whenever they need them, and restraining contaminated items from the reaching stores. The World Health Organization is working with blockchain and other technical companies on a program to help convey data about ongoing COVID-19 pandemic, like named Need Pasta, that is MIPASA. Actually, that is a program. This program actually is a distributed ledger technology that will hopefully help with early detection of a virus and identifying carriers and hotspot. So with that, we just discussed how the role of blockchain in COVID-19, how it can help to come out of the COVID-19. The next we'll discuss about various use cases pertaining to health blockchain, that is healthcare. Okay, so in what way the healthcare, actually in the healthcare, whatever the use cases we are discussing, we will be discussing with respect to the issues. Already we have some issues in a particular application. What is the role of solving the issues of blockchain? Okay, so the issues with the healthcare is lack of complete understanding of patient medical history, and here we'll be having fake medicines. That is also possible, no? Here, the role of blockchain is it serves as a tamper proof and get a better idea of patient's medical history, and we can tag and track drugs in supply chain management, so that it will have the entire control over the data. And we have, these are the two organizations who works on providing blockchain technology for healthcare application, that is RoboMed and Patientary. And with respect to supply chain management, usually these two are the major issues we'll be facing in supply chain management, that is lack of transparency and product authenticity. Like here the role of blockchain is products to be tagged and assigned, then tracking import, that is the important product are to be tracked in an efficient manner, and verify the authenticity of purchased goods. Okay, so by doing this activity, they are try to solve the transparency and product authenticity issues. And these two are the famous organization who provide the solution for supply chain management using a blockchain, that is Walmart and Maersk. Then we have voting machines, and I have planned to show one demonstration using voting mechanism only. That after a couple of slides, I will show the demonstration of it. Then voting mechanism here, voters registration database. Okay, the data maintaining the database is very difficult, and identity may be used by some other person, and a collection of vote also, it is a tedious process. Whereas here, in the with respect to blockchain, it provides the blockchain database so that no one can tamper the data is available in the database, and it will be using a biometrics, and it is transparency to everyone. And these are the two blockchain software with respect to voting mechanism, that is vote Z and follow my vote. And so personal identity security, actually it is like a personal details, it is unaccessibility. Then for example, let's say other card, we are facing a lot of issues with respect to changing the data, and if you want to change our own details, then we need to process, we need to come across a lot of process, right, in order to change our data in the other code, right? But here in the blockchain, it can be done in a easy manner. Actually, we do have certain issues with respect to personal identity security, like inaccessibility, data insecurity, then fraudulent identities. So here we provide, we'll be having decentralized identifiers. There is no central authority for maintaining your personal identity. Then here we have efficient identity management, and here and also the blockchain provide a embedded encryption feature for maintaining our personal details. Then we have in the next application is the real estate processing. So here the issues like high fees for a third party platform, like we always dependent on intermediate, or we can say broker. No, we need to spend some amount of some percentage of amount to the broker. That is the major issues we do face with respect to real estate processing. Then physical proof of identity, maintaining the physical proof of identity also, it is very difficult. Then property management, it is very complex. But here, by using blockchain, by incorporating blockchain technology in the real-time estate processing, here it is a decentralized database, and we do follow the digital identity, and we'll be having a smart contract. Okay, so by with the help of these features, we can avoid certain issues with respect to real estate processing. Then other use cases also, we do have Internet of Things, intellectual property, food safety. So these are the some other applications where we can incorporate blockchain technology. I think I'll stop with this. I will show you the demonstration of blockchain technology using voting mechanism. That is voting mechanism using blockchain technology. I just stop my presenting. Give me 2 minutes time. I just open the record applications for that. Do you have any doubts so far?
Participants, if you are having any doubt, kindly unmute and ask or post it in the chat box. Participants, if you are having any doubt, kindly post it in the chat box. Bairam, you can please share.
Okay. Um, okay, I'll share my PPT. Uh, okay. Actually, this is one of the applications where we can incorporate blockchain technologies. Actually, um, the objective of the project is to create a voting system which ensure the fairness and transparency in election, and it offers security, immutability, and verifiability. Okay. So the system architecture is like the voting process starts with authentication by entering our user credential. Okay, and then the private key for a particular block is a validator. Okay, once the private key is a validator, the voter is allowed to cast their vote. Okay, so for when they're for validating the user credential, the corresponding smart contract is executed. Actually, that is the action, right? User entering their user credential. That time, automatically the corresponding smart contract is executed in order to validating the user credential. So once the user credential is validated, then the voter allowed to cast their vote. So the vote is recorded as a transaction and it is stored in a block and added to the blockchain network. Okay. So what is the transaction we are going to perform here? That is the casting of vote is the transaction. So before casting the vote, the user need to enter their detail. That is nothing but the private key. So after that, once the user casted their vote, then it will be added to the already existing blockchain. Okay, so this is the entire architecture of voting mechanism using a blockchain technology. So here the design considerations, what we have considered means the voting system should verify the identity of voters and authenticate only eligible voters. Then any voter should get only a single chance to vote. That is, the system should prevent double voting. Then it should provide a complete privacy to voters, and the vote should not be traceable. It should not allow a tampering with the votes and casted by anyone, and the system should not allow a single authority control on counting. Okay, so these are the design constants we have considered for designing this project. And here they have used Ethereum blockchain technology. Actually, it is a decentralized open source blockchain featuring smart contract functionality. So Ether, actually, it is the native cryptocurrency token of the Ethereum platform. Whenever we are performing a particular transaction, the some amount of Ethereum is considered for executing a particular transaction. And here we have used like a proof of work as the consensus algorithm. So what is the proof of work? Actually, proof of work is it applies some mathematical puzzle to solve the sorry, it perform mathematical operation in order to solve the puzzle. Actually, the proof of work, it is for validating the transaction. Okay, so here we have like in the server, it will perform the puzzle. So if they are able to solve this puzzle, then it will check for the solution. Okay, so then solidity. Actually, solidity is an object oriented high level language for implementing smart contract. Okay, so actually it is one of the language like C++ for writing our smart contract. So solidity is statically typed, support inheritance libraries and complex user defined types. And the smart contract, as we know that the smart contracts are trackable and irreversible application. Once the smart contract has been deployed, nobody can edit the code or change its execution behavior. So each smart contract will be deployed at a particular address. So still the people have trust issues with electronic voting machine, for which the smart contract might be the right solutions. Okay, so once nobody can able to trap your nobody can able to change the casting of vote. Then actually this is the place where your blockchain is created. So once the block is created, you will be provided with the amount you have, that is in terms of Ethereum. Then the bytecode for the smart contract. Okay, then you'll have a deployer address. Okay, so for every user provided with an address along with the private key. Okay, so this is how your blockchain looks. Okay, then MetaMask, actually MetaMask, it is used to handle the account user credential. Okay, so only through that MetaMask account we could able to connect the user to the blockchain, and it is the easiest way to interact with the developed applications in the browser, and it is mainly used for authentication, and it is available as extension for Chrome and Safari. I'll just show you how to create an uh, account in the MetaMask. Okay, and so this is how your MetaMask looks. Actually, here we can choose what type of network we are using. Actually, we have different blockchain network, Ethereum network, Rockstar network, then local host network. Okay, so we need to choose what type of network we are going to use for creating a block. Okay, so using the MetaMask, we can easily switch between various blockchain network. And the center picture, it shows the actual view of your MetaMask. Okay, it will show the account address and the balance amount you have in terms of Ethereum. Since we are created the blockchain using Ethereum network, so it will show the balance amount in terms of Ethereum. Okay, then here the third one, the last one, shows what type of transactions we have done with respect using through that MetaMask account. So that will be displayed here. Okay, so using a MetaMask, we can choose a type of network. Type of network we are going to work. Okay, so there are different types of networks are there. Local blockchain network, Ethereum network, then a Rockstar network. There are a lot of networks are there. So from that we have to choose one network, and then the second one display the account details. Okay, so what is the balance amount you have in terms of Ethereum, then the account address, your name, everything will be displayed here. And in the MetaMask, we also track what are the transaction we have did so far. So that kind of activity can also be tracked through your MetaMask application. Okay. So here, that is how the local blockchain is being created. Ganache is the one of the software. It just a personal blockchain for rapid Ethereum distributed application development. It features a graphical user interface that can simulate a blockchain network, and it can be used to test the smart contracts without requiring you to set up a real test networks or using a remote net. So some simulation kind of blockchain network can be established through Ganache software. And initially, it provides 10 accounts with 100 ethers in each account. So this is how your Ganache looks. Actually, here we can track account, what are the account we have in the network, and how many blocks we have created, how many transactions have been carried out in the particular blockchain network. Then contract, what contract we have assigned for a particular blockchain in order to carry out the transaction, and event logs, anything can be viewed through your Ganache software. I'll explain each things like when I show the demonstration. And here, this is about like a block, how many blocks we have. When you click on a block, how many blocks we have between particular duration, how many blocks we have created. Those details can be displayed. And this is about a contract. Okay, so where actually the contract is located, the address of the contract and the name of the contract, everything is can be displayed when you click contract button here. And Truffle, it is a development environment testing a framework. Okay, so using this actually Truffle, it is a base. Okay, on the Truffle only we can able to execute Ganache, unless we can execute our blockchain network. So based on Ethereum blockchain and design to facilitate the smooth and seamless development of dApps. That is, with Truffle you can compile and deploy smart contract and also develop front end for dApps. And through the Truffle, we can integrate compilation, testing, and deployment of smart contract. Okay, so because when we perform particular transaction on a blockchain, smart contract is very important, because through that smart contract only we can able to validate the blockchain, right? So by executing a smart contract for we need a Truffle environment. For executing a smart contract we need a Truffle environment. And this is one sample smart that is small doc details in terms of command line manner. Okay, so we can either we can create a blockchain network through the command line prompt, or graphically also we can create we can see the details of every block. Okay, so here it just represents, these are the various fields we have in every block. That is the number, block number, hash value, then parent hash, then nonce, then these are the very important fields like number, hash, nonce, then gas limit, timestamp. Okay, the transaction, what transaction we did pertaining to particular block. Okay, so these details can be retrieved. Actually, these details can be available for every block. And this is the picture, like the homepage of blockchain election. And I'll okay. I just show you the a demonstration for whether we need to pay here for accessing the Ganache network. Yeah, it is open source only. Since it is just an local blockchain only, using Ganachi we can create a local blockchain. It doesn't require any amount to be paid. So you can easily download it from the net. Probably I'll share the particular links. Okay, I just stop my presenting for a minute. I'll just give you the link. Through that you can download your Ganachi. Yeah, give me a minute. I just take those links. So for developing an application in Ganachi, you need to have a Node.js. Actually, this link is for downloading a MetaMask. MetaMask is just an extension. You just another plugins, you just download it and make it as a Chrome extension. And for Ganachi, you can use this link. Ganachi, you can use this link, and for Node.js, so this link where you can find Node.js software, all are open source only. You can download it openly, and then you can install it in your system. And okay, see, actually, this is what. Okay, let me share my screen first. Actually, I already set up an environment for a local blockchain network in my system that requires these software like MetaMask and Ganachi. And you need to have a Node.js because our blockchain voting mechanism is designed with the help of Node.js only. And see, I hope you can able to see my screen, right?
Yes, ma'am.
Yeah, okay, thank you. Actually, it is available. Actually, in my drive, I have a folder called local voting. So here, this is what the required. packages and files in order to in order to set up a local blockchain networks. Okay. See, actually, what you're supposed to do means like in command prompt. It is already running. I think I'll see the timings. Oh, okay. We have 43 minutes left. Okay. I just I just close this. Okay. So in the command prompt, uh, so here first, what I supposed to do means I need to um, start our I need to first create a truffle environment. So first, I should execute a truffle migrate. So this will execute the smart contract actually. So your contract, you that has to be created. Okay, it is already compiled. So now I'm just executing npm start. That is the command to initiate your local blockchain. Actually, it is a so what I'm doing is Control C. I actually this opened in Internet Explorer. Since only in the Google Chrome we have MetaMask. See, actually this is the home page of your um, voting mechanism application. Okay, so here in the extension, I'm just see the if you have already installed in the extension, when you click extension button, where you can see the icon of MetaMask. Okay, so here I already created 4 accounts. Okay, so whenever the blockchain, that is whenever we start the blockchain network, why it is coming like it is closed. Mm, okay, I'll execute again. So here, actually, when I click on the MetaMask icon in the extension near the extension button, you can see the MetaMask icon. Okay, so here you can choose the account details. Actually, when we start the okay, I'll just close this. Okay, I'll just close this Kanachi and again give me a minute. Actually, the voting is closed. It shows like that. But, actually, it should not come like that. Mm. Okay, our smart contract is compiled. Now I'm executing. When I open this, then actually it takes some time to load. Yeah. Okay, when it is started, that is when we start the creation of a local blockchain network. So your Ganache will, as I told, your Ganache is capable of holding 10 accounts at a time, and each account provided with the balance of 100 Ethereum. Okay, so if you see here, we have like these are all the 10 account details pertaining to our voting mechanism. Okay, so here we can see this is about account details. We can see the address of account, then balance, and the transaction count, the how many transaction they have conducted so far, the transaction count for a particular account, and the private key. So here we can see the private key for each and every account. As I said, for a performing particular transaction, we need a private key. That is the key point where a particular user can perform the transaction. So private key is very, very important. Okay. So this is like in the block we have we so far we don't create any block, right? Okay, so it is just now I have created the local blockchain network for a voting mechanism, and we didn't perform any transaction, and the smart contract. So actually I didn't import the smart contract here, and we don't have event now, and there is no logs also. Like these are all like it tell about what all the block we have created, and what transactions we have performed. Everything is stored and it is logged here. You can see from it here. Okay, then so I just minimize this, and you see that we don't uh, mm, these are the account details, and we didn't create any block so far, and there is no transaction is done so far. Okay, so now I'm just mm, so something going wrong actually. Okay, so in the MetaMask, um, so here when you, that is we already I already have 4 accounts over here. If you want to import a new account, then you can choose, you just click on the circle button at the top corner in the MetaMask window, where you can find what all the account we have with respect to this MetaMask. Then we can, if you want to create a new account, you can create it, or if you want to import an account, that is that also possible. So let's see how to import an account. Okay, so you go to your Ganache Ganache application, where you can find a list of address, right? Okay, so you choose any one of the address, and then you choose select the private key. Okay, so you just copy this private key, any one of the address. Okay, you just copy the private key, and then you can in the MetaMask for importing an account. Okay, so here you just paste your private key, and then you just click on import button. Okay, so now the account is created, and now you are ready to cast your vote. That is your whenever you are pasting your private key here, the corresponding smart contract is executed. Okay, and then you are allowed to cast a vote now. Okay, so now I'm just uh, actually here it shows some error. Local voting. As I said, no, that here we can choose a type of network we want to perform a particular transaction. For different blockchain networks are there. Mm, it shows an error. So here we can see for a particular account in which network it has been connected. That details can also be tracked. So it has been moved to okay, account 4 is connected, and they have a balance of 0 Ethereum. I think there is a problem actually. Yeah.
ஓ எங்கேயோ ஒண்ணு இருக்கு. உனக்கு எங்க கிராஃபிக் இருக்காது, ஒன்றும் பிரச்சனை கிடையாது. இந்த லாரி பின்னாடி முன்னாடி அடடா மிஷின் திறந்துதா இல்லையா கவனிக்கலையா? திறந்தா கொஞ்சோண்டு கோதுமை எடுத்துன்னு வந்து பறிச்ச பூரியும் சப்பாத்தி எதையும் செய்யணும். திருப்பி சாப்பிட்டு இறங்கி
Pratika ma'am, kindly mute.
ரத்திப்பா மேம்,
Uh, yeah, see, participants, please give me a minute. I have a problem in the blockchain network, so I just rectify it and I'll come back. Just 2 minutes.
Pratibha ma'am, kindly mute your audio. Prateepa ma'am, kindly mute your audio.
Yeah. Okay. Actually, I got it. Actually, what happened means, before starting this session, I have executed this local blockchain network once. So actually, in that network, so voting they have mentioned particular time within an 1 hour. Every user have to cast their vote. So that is why it is keep on displaying closed, voting closed. So again, I started the blockchain networks. So actually, when you start your a local blockchain, you'll be provided with this kind of application. Okay, so like this is the user interface. It will display the user candidate name along with their icon. So here, first what we supposed to do means we need to select the account through MetaMask. I hope everybody can see my screen, right?
Ah,
Yes,
yes.
ma'am.
Yes. Okay. Okay. Thank you. So here we can choose the account. It is connected and it has zero balance. So I am choosing another account. So okay. I'll import another account so that it has maximum balance to perform the transaction. I'm just choosing this. You can choose any account from this. So this is what the private key. You have to copy this private key and in the MetaMask. So, so click on import account. Here you just copy this private key and you can select import. Mm, it shows like that. Okay. So now it is validated. Like we have 100 Ethereum now. So now we have chosen the account 6 and it is not connected You can make this as connect. Okay. Um, okay. So now here you can select the candidate and choosing. Okay. So now I'm just putting. So once we click vote, actually you're around 96. So setting up the network, actually it is very, very important. So just yeah. So when we vote, actually when we vote, the corresponding account detail is displayed in the MetaMask. Okay. So now the amount of Ethernet consumed for performing this transaction is that it has been shown here. That is 0.002012. Okay. So now we'll be confirming this transaction. So once it is confirmed, your casted vote is updated over here. That is for I have casted vote for Divakar. So it is the count is increased one here. Okay. So now you can, if you go to your Ganachi, where you can see the blocks, that is that particular time you have created one block, that is block 5 has been created here. Okay, so this many blocks we have created so far, and the transaction details also displayed over here, like the transaction hash value, then the contract address where your smart contract is located. Okay, and the gas used, that is the amount used for performing a particular task. Everything is updated over here. So previously I have shown that the transaction, when I click on transaction, nothing has been displayed, no, but once you perform the transaction, these those transaction details are displayed over here along with the hash value. And so this is how your local blockchain is created. Okay, so if you want to cast for another account, like in the Ganachi, like you can choose another account to cast a vote. Then by giving okay, I'm choosing this account for a casting and vote. So I'm just copying this private key. Okay, in the MetaMask, okay, you import a new so it has a full amount of Ethereum, so that they can perform this task. Okay, so now again I'm executing this mm, okay, I'm choosing the, so account 7, it is actually not connected, so we need to connect it. So now okay, it gets repeated. Okay, so now I'm selecting another name. let's say Manovidya, and I'm just voting it. So now it will check the for the seventh account. It just mention the amount of Ethereum to be spent for carry out this transaction, and we need to confirm it. Okay, so once it is confirmed, already in the previous transaction I casted for Diwakar, and the next using the next account I casted for Manuvidya, so that it is voted. So any user who is having a proper user credential, they can view the number of transactions they can view the number of vote for a particular candidate. The thing is, like for especially for voting mechanism, before voting a cast, you could not see the count of a particular candidate votes. That's not possible. Once you performed the transaction, that is how we have designed this system. So once you casted your vote, after that you can see the number of vote casted for a particular each and every candidate. So that is how we have designed our system. Okay, uh, so this is what I would like to show show to you all about the demonstration of blockchain, how the local blockchain is being created, what are the various software involved in creating a blockchain, how it is the account can be validated. Do you have any doubt in this? Yeah, with that I am stop my presentation. So that's all from my side.
Thank you, ma'am. It
Yeah,
was really an informative session for all of us. Participants, if you have any doubts, kindly post it in chat box.
yeah. My email ID is tm.it@shiptech.ac.in. You can see it in the chat box. So in future, if you have any queries, you can feel free to mail me through this mail ID.
Okay, thank you.
So, no
Your
doubts?
most, yes.
Yes, ma'am, you can proceed.
Okay. Your most exciting talk on blockchain introduction and evaluation will be very useful for every participant. It was really an exciting session, ma'am. We are sure all the participants would have attained a good knowledge on what is blockchain, its types, and its key features, components, and how does the blockchain works, and evaluation of blockchain use cases, and blockchain and COVID-19, etc. And once again, we all thank you for your valuable ideas. It will certainly improve our ideas on blockchain. We are eagerly looking forward for more such interactions in the year to come.
Yes, thank you, ma'am.
Thank you.
Yeah, thank you, participant, for your patient listening. And I must thank Dr. Kyle Willy, Associate Professor, who has given me this opportunity to deliver lecture on blockchain introduction and evaluation. And also, I thank Dr. Jabin Begum ma'am, HOD, CSC, and Lata Jyoti ma'am for giving me this opportunity. Uh, Thank you once again.
Thank you all. Thank you, Vairam. Participants, we will meet tomorrow exactly at 10 a.m. sharp. Thank you.
Thank you.